So let us look at the next problem. So we are given AOB and COD are two straight lines which bisect each other at right angles. Show that the locus of a point which moves so that PA into PB equal to PC into PD is a rectangular hyperbola. So we are given two straight lines and the straight lines are bisecting each other at right angles, and let P be any other point. Okay. We need to show that. So let P be a point xy, an arbitrary point xy. Then we need to show that the set of all points P such that PA into PB equal to PC into PB. So set of all points xy which satisfy this condition will form a rectangular hyperbola. So let us take the points A and B. So let us take the point O to be the origin. അപ്പോൾ origin എന്ന് perpendicular ആയിട്ട് intersect ചെയ്യുന്ന രണ്ട് lines എടുക്കുക. So they can be lines on your x-axis and y-axis. അപ്പോൾ x-axis ഉം y-axis ഉം ആയിട്ട് എടുക്കുക. ഇനി A യുടെയും B യുടെയും coordinates. So since origin is bisecting the coordinates, so coordinates will be of the form. So take it in the form A0 and minus A0. So origin will bisect the line AO. അതുപോലെ C ന്റെ coordinate OC ആയിട്ട് എടുക്കുക, and D will have the coordinate 0 C and 0 minus C. So here the lines, since they are on the x-axis and y-axis, they will be perpendicular, and for this choice of coordinates they will be bisecting each other. So the origin will be bisecting the lines AOB and COD. And let us take XY to be a point on the plane such that it satisfies the condition PA into PB equal to PC into PD. Now let us write down these distances PA, PB, PC and PD. So P will have coordinates xy, then A the coordinate A0 varum. So the distance PA will be root of x minus a whole square plus y square. Then for PB you will have x plus root of x plus a whole square plus y square varum. PC ke root of x square plus y minus c whole square, and for PD you will have root of x square plus y plus c whole square. Now squaring on both sides you will get this. So when I expand you will get x square plus a square plus y square minus 2ax varum. Then the second one expansion will be x square plus a square plus y square plus 2ax, and on the right side you get x square plus y square plus c square minus plus 2cy varum. Then x square plus y square plus c square minus 2cy. Now this is in the form a plus b into a minus b formula. A square minus b square varum. So you will get x square plus y square plus a square whole square minus 4a square x square equal to x square plus y square plus c square whole square minus 4c square y square. Now let me expand this in the form a plus b whole square. X plus y whole x square plus y square plus a square, and I am going to expand in the form a plus b whole square. So that will give x square plus y square whole square plus a raised to 4 varum plus 2a square x square plus y square minus 4a square x square. So that is equal to x square plus y square whole square plus c raised to 4 plus 2c square x square plus y square whole square minus, no, whole square is not there. Okay. Minus 4c square y square. And now this e term cancel out. Ni ഇവിടെ x square. Okay, let me take now the coefficients of x square and y square. So x square and okay, let me simplify this. So a raised to 4 plus ഇവിടെ 2a square x square and ഇവിടെ minus 4a square x square. So you get 2a square y square minus 2a square x square, that will be equal to c raised to 4. ഇനി ഇവിടെ 2c square y square cancel ആവും. അപ്പോൾ 2c square x square minus 2c square y square വരും. Now take the coefficients of x square and y square to one side. അപ്പം x square ന്റെ coefficient എടുക്കുമ്പോൾ, okay, so you will get, so take everything to the x square and y square വരുന്ന terms റൈറ്റിലേക്ക് കൊണ്ടുപോവുക. അപ്പോൾ ലെഫ്റ്റ് സൈഡ് you will have a raised to 4 minus c raised to 4 equal to 2c square plus 2a square x square വരും. Then minus 2c square ഇങ്ങോട്ട് വരുമ്പം again plus 2a square y square വരും. So now 2c square plus 2a square is common here. അപ്പോൾ divide ചെയ്യുക throughout ആ term വെച്ച്. So that will give x square minus y square equal to, so you will have a raised to 4 minus c raised to 4 by 2 a square plus c square. So that implies you have x square minus y square equal to a square plus c square cancel out. So you will have a square minus c square by 2. So therefore we get the equation x square minus y square equal to a square, where you will have a equal to, sorry, a square equal to a square minus c square by 2. So which is a rectangular hyperbola. So therefore the locus of the points will form a rectangular hyperbola. So that is the proof of the result.